Okay, this is going to be artifact number 3 in the category of databases. And I've chosen Project 1 assignment from the course DAD 220. And I'm going to do a walkthrough of this PDF file that shows what we did in the Codio environment. For my enhancement, I'm going to use the MySQL environment. But I'm going to right now do the walkthrough, and then we'll do the code review and talk about enhancements. So what we first did in here was to log in to MySQL, and we looked at the databases that were in the system earlier in the course. We made one with our last name, there's mine, and we had some, as you can see over here, CSV files already provided. We had customers and orders and the fleet maintenance records. We had a few that we worked with. And I'll run through each of the different tasks that were assigned and show what was entered to complete them. Sorry about the rapid scrolling here to get to these screenshots. Now here we were asked to create a database called Quantigrations Update. So we showed that the databases didn't have one yet. So here's the command to create that one. And then we show the databases again and we see it's in there. Okay, now we want to add some tables to it. So we created a table called customer. And these are the parameters that we were asked to add. So we had a customer ID, which we assigned the primary key. So that one would have the unique value, and the not null indicates that it can't be 0. It's got to have something, and it's always going to be different. And then we had first name, last name, street, city, state, zip, and telephone number. And the varchar, the various characters, and the limit. So this one can only have 25 characters, or I should say up to 25. 25 again, then 50 for street, 50 for city, 25 state. Zip code had to be an integer, and telephone number up to 15. And we added those, and then we described customer, so we saw what was in that table. And they came out just fine. Now we did that again. Forgive my rapid scrolling. And we created an orders table. And then we added order ID, customer ID, SKU, and description. And we did that. And we also wanted orders ID and customer ID to not be null, and it had to be an integer. Okay, now we created a table named RMA, return merchandise authorization, so we did that, and we will have RMA number or ID, order ID, step, status, and a reason. Okay. Now what we did was we used the CSV files that were preloaded to upload the data from those onto the tables that we created. So here we're showing the command to do that. So we loaded the data from the customer CSV into the table, orders, RMA. Now, once we had the data loaded, now we can do some queries to retrieve some information here. So the first one was to see the return get a count of the number of orders for customers located only in the city of Framingham, Massachusetts. So we did that. And we did it right here. So the command was select count customer inner join orders on customer.customer ID. It's going to equal orders.customer ID, where the customer city is Framingham, and the upper customer state is Massachusetts. Sorry, that cut off a little bit, but we got 505 records returned for that city. Then we did a SQL query to select all the customers located in the state of Massachusetts. And here's the command for that. Select count from customers inner join orders on customer.customer ID equals orders.customer ID, where upper customer.state equals Massachusetts. And we return 982 records. Okay, now we were tasked with adding some data. So we wrote a SQL query to insert these 4 records into orders and customers. So in the customers table, we were asked to input this. And down here it shows how we did that. So into the customer values, entered that, and then we selected it to see, and we sorted by, or we queried rather, by customer ID, and we pulled them up. So we saw that these 4 rows were successfully added. Okay, here we were asked into the orders table to input this data, and we did that, and I had an error which I even fessed up to here. Instead of putting in the 1204307, I put in 1207, and at the time I didn't know how to fix it. I do now, but when I did the assignment I couldn't, so that's how it went in there. Okay, and then we were tasked with sorting to see, or querying rather, all the records in the city of Woonsocket, Rhode Island. How many would come up when we did that? So we did a select count, asterisk from customer, where customer.city is Woonsocket, and we got 7. Okay, now we were asked in the RMA table to look specifically for the order ID with the value of 5175, and they asked what was the current status and step. So when we did that, we searched, we found that the status was pending, and the step information read awaiting customer documentation. So then we updated that record to show that the status is complete, and the step was credit customer account. And we made that change, we updated that, and we have a status of complete and a step reading credit customer account. Okay, now we were tasked with deleting RMA records where the reason was rejected. So we did that. And doing that affected 596 records. So those were deleted. Then we were asked to rename all instances of customer to collaborator. And again, at the time, I didn't put the commands in exactly like I was supposed to, but since then, I've been able to find out exactly what I needed to do that, so I could do that in the future successfully. Then we were asked, went past that, create an output file. So we were asked to write an SQL statement to list the contents of the orders table and send the output to a file that has a CSV extension. So to do that, we put in this command and we tested it, and we saw that orders3.csv existed over here, so it was successful. And that was the assignment for project 1. Okay, now let's do a code review. Now, code review for databases is going to be a little bit different. Now, this code appears to implement the design correctly, creating tables and performing SQL operations as described. The code does not explicitly conform to a specific coding standard, but it follows common SQL syntax conventions. The code is well structured, consistently styled, and formatted appropriately. There are no uncalled for or unneeded procedures, unreachable code stubs, or test routines in the code. The code does not appear to call external reusable components or library functions since it's SQL code. There are no blocks of repeated code that could be condensed into a single procedure within the SQL statements. Storage use efficiency depends on the underlying database management system. Symbolic names are not applicable in SQL. However, column names are given meaningful names. The modules, the SQL statements, do not seem excessively complex and do not need any restructuring. SQL code typically lacks inline comments since the queries themselves are self-explanatory. However, in a real-world scenario, comments can be added to explain the purpose of certain queries or complex joins. SQL does not use variables in the same way as traditional programming languages. Column names and data types are defined consistently. SQL queries do not contain arithmetic operations or comparisons involving floating point numbers. Rounding errors are not applicable to SQL in this context. The SQL queries do not involve additions or subtractions with greatly differing magnitudes. There are no divisors tested for 0 in the provided SQL queries. SQL does not contain explicit loops or branches, as it primarily deals with set-based operations. The SQL queries do involve conditional statements, example the where clauses, that are correctly structured. Since SQL queries are set-based, there are no loop termination conditions or index variables. SQL queries do not explicitly test indexes, pointers, or subscripts against bounds. Input arguments are not explicitly validated in the provided SQL queries. Output variables are not applicable in SQL. The SQL queries operate on the correct data, assuming that the table structures match the design. SQL queries do not involve memory allocation or deallocation. Error handling for external device accesses and file existence checks are not relevant in this SQL code. There are no file operations in the provided SQL queries. So to summarize, the provided SQL code appears to be correctly structured and follows SQL conventions. However, additional comments could improve readability and maintainability in a real-world context. Since SQL is a declarative language, many aspects of traditional programming don't apply. Now, for the enhancements I'd like to do for this artifact, I noticed that, given the test environment and the fact that you had to log into the system to gain access to work on it, that's how security was handled from the school end or my personal computer end. But what I'd like to set up for this artifact is go into the MySQL environment and put in place authentication plugin, so that you would have to, set up a user ID and a password to access a given database, which is something that I will construct. I will make a database that you can access, and I will demonstrate some functionality once we get in there. Another enhancement I'd like to do is set up encryption. So we'll have an authentication plugin, then encryption, and then once we get in, I'll be able to demonstrate a database set up. I'll use the information that was in Project 1. I'll create exact same tables, and then I'll demonstrate the CRUD functionality. So for CRUD, C-R-U-D, C for create, R for read, U for update, and D for delete. So I'll demonstrate that functionality in the database that I create for Artifact 3. Now, in doing that and setting up the security protocols, that'll aid in my development of a security mindset that anticipates adversarial exploits in software architecture and designs to expose potential vulnerabilities, mitigate design flaws, and ensure privacy and enhance security of data and resources. In a real-world environment, these are the things that you definitely want to incorporate when working with data. I personally, when I took my class in security, I was convinced after about a week that I needed something like Norton Antivirus. All these years of working with computers, I would on and off use different programs or use different scans, but as soon as I realized the threat of hackers and just the vulnerability of all of it, that's when I really decided I'm not protecting my system the way I need to. So since then, and that was about 2 years ago, that's when I decided to employ security measures like that. So that concludes my code review for Artifact 3 databases. Once again, thank you for your patience and your attention in this matter.